Hi everyone, this is Billy. In the last video, I told you how to create an untunable crystal radio for FM crystal radio reception. This allows you to test if you got the right environment to listen to FM crystal radio. Today, I'm going to show you how to build a tunable FM crystal radio using the slope detector circuit. So what is slope detection? It is a method to convert an FM frequency modulated signal into an AM amplitude modulated signal. And this way, we can detect it using a conventional crystal radio circuit through a diode or an MOSFET like 3DQ, or even crystals, if you find crystals that work at that high frequency. So to receive an FM radio station, we tune our crystal radio's resonance frequency, meaning the variable capacitor, to a frequency slightly higher than the center frequency of the FM radio station. For example, if we want to receive 88.1 MHz, that station, we tune it to 88.105 MHz, something like that. Then, as the frequency modulated carrier moves in and out of the receiver's resonance frequency, the amplitude of the signal detected will also vary, like going up or down the slope as shown in the diagram. So this is the term slope detection, how it comes about. Once we operate like this, we'll be able to receive an output that is similar to that of an amplitude modulated signal. However, the resulting signal is an approximation only, and it's not a one-to-one linear ratio between the detected AM signal compared with the original FM signal. However, this is a way we can still receive the FM radio broadcast. Of course, this is simple and easy to build. Anyone can build an FM crystal radio because it's just another AM crystal radio. You just need to find the right coil, variable capacitor, the right antenna, then off you go. You have an FM crystal radio. So a lot of people ask me, hey, this is AM, not FM. Well, they probably have right because we did convert the FM to an AM, then we receive it. But the original music and speech are really that of the FM radio broadcast. We are just converting it to AM so we can receive it. And the disadvantage of that is because it's a very simple approximation. We are not really detecting or converting the FM modulated signal to demodulate it in the original FM way. And to do that, we need to have more complex circuit like the Foster-Seeley or the ratio detector circuit. Sometimes we need to use integrated chip to achieve that, which is not possible with crystal radio. So for crystal radio, the easiest method is the slope detection. So this is our FM crystal radio circuit for slope detection. We're using the diode as the detector. On the left, you can see the capacitor C1 and the coil L1. They make a resonance circuit for the FM frequency range. And we have the input to the resonance circuit through the Yagi antenna or the dipole at the top. For the output, it will be filtered by the 150 picofarad capacitor to smooth out the audio and remove the high frequency component of the signal. That high frequency component will be sent back to the resonance circuit to boost it up to even better. This is an equivalent circuit to use with the MOSFET, the 3DQ, which will create even better outputs. The circuit is similar, only that we have more terminals coming out of the detector. We have the gauge 1, G1, and gauge 2, G2. G2 is connected to the hot end of the coil, G1 connects to the cold end or the ground of the coil, and then we have S and D. S is the source. It is the source that absorbs the current from the resonance circuit, and that feeds through the MOSFET to the drain. Drain drives the speaker or the headphone, and depending on the signal's amplitude variation in G1 and G2, it will control how current passes through the source and the drain, thus doing the detection part of the slope detection circuit. I want to show you the different type of variable capacitor that you can use to make your FM crystal radio, like this one. So the best one is these copper ones, copper air variable capacitor. As you can see, it's insulated by air, and the moving plates and the fixed plates both are made of copper. So this is a bigger one, this is a smaller one. Now let me test the capacitance. So this is the capacitor meter, LC meter, and let me mount it here and test the capacitance. So if we have the maximum overlap, capacitance is around 16 or 17 picofarad, and then when it is least overlapped like this, it's around 3 picofarad. Okay, what about this bigger one? Not around 19 picofarad. I move it to least overlap. It's around 3 picofarad. We often see is this type of plastic ones, and they're insulated by plastic films. So let's test one by one. This is the small one. This one is only used for FM radio. Okay, this one starts with around 21 picofarad and all the way down to around 2 picofarad. And then we have this type of multi-purpose one. One side is for AM radio, one side is for FM radio. So let's test the side for FM radio. 30 picofarad, and it go down to around 9 picofarad. So this one is a little bit big, so you can only use small coil to match this one for the FM radio. However, if you use the other gain in series connection for the two fixed plates, then what happens is you can get a smaller variable capacitance from 3 picofarad to 15 picofarad. So this type of variable capacitance is better for FM crystal radio because you can make a bigger coil. Okay, so either you connect the moving plates with the fixed plates and use a small coil, or you connect the two fixed plates of the two gain and use a smaller coil. So to make this FM crystal radio for the slope detection circuits, you will need the following component. First, you need to get a small case. Should be plastic. If you use the metal case, you need to be careful that it has enough space so the coil and the capacitors will not be too close to the case, otherwise it will impact the resonance frequency. Okay, even though a sealed metal case is good, but for beginners, I think you can start with the plastic case first, otherwise it will be hard to manage. Like drilling the holes will be very tough on a metal case. Okay, so once you have the plastic case, you drill a few holes. So we need to drill 3 holes for the M4 screws that we will use to connect to the antennas. For antennas, you can use the wire to connect to your Yagi antenna for FM, or if you don't have such antenna, you can use this type of extensible telescopic antenna for radio. You need to buy the one that can extend to over 1 meter, 1.2 meter, for example this one. And then there's a screw. The screw here, you need to match the size of the screw on your antenna. Some are M3, some are M4. Mine are M4, so I just use the M4 screw to mount it. You see, it can be mounted securely, and then you can test your FM crystal radio outside easily. And then when you try to use it indoor, you can just unscrew the extensible radio antenna and then use the elevator clip to clip to the terminal here from your in-house FM crystal radio. So we need 3 terminals for the antenna. I'll tell you why when I show you the circuit diagram. So one is for the main antenna, and then the other one is for the second half of the dipole. The second half of the dipole can connect to 1 or 2 terminals depending on what type of antenna you're using, because there's a impedance matching of antenna, so I have 2 poles. If you're using folded Yagi antenna, you connect to one of the poles. If you're using just a telescopic antenna or just a simple dipole, unfolded dipole, then you can connect to the other antenna. Okay, so I created 2 boxes, one for use with the plastic variable capacitor. So I drill enough holes so I can mount the VC this way. There's a big 6mm hole at the middle, and then 2 small 2.6mm hole at the side. So and then you want to orient your variable capacitor this way, because on this terminal you'll be able to solder the coil, and the coil will be like this. So it will be made using this 1mm wire. It will be better if you got a 2mm wire, but for beginners 1mm wire is also okay. So you create a coil using the 1mm wire, using the AAA small size cell, AAA cell as a frame to wind 6 turns, and then you can put in here. Yeah. So that's why the orientation needs to be like this, with the terminal extending to the side, so you can solder it nicely here and put it in place like this. Okay, so for this one I will be using the air variable capacitor. There's only 1 mounting hole, so I just drill 1 hole, and then the same way the coil will be extended to this way. The other thing you need is the ear jack, the jack for your headphone. So we use the stereo 3.5mm jack. You need to connect a 100 pf capacitor, fixed capacitor, in parallel to the terminals of the ear jack, so that you can filter out the high frequency wave from your audio, and this will both make your audio sound better as well as feedback all the unwanted high frequency back to the resonance circuit, so you can enhance the resonance circuit. The other thing you need is a detector. So I want to make this radio more flexible, so you can switch different type of detector, like different type of diode or different type of MOSFET, the 4-leg MOS-FET, like the 3DQ. So you can try out different type of detector and see which one sounds better. We use the 4-jumper type socket and the one with threads, so you can easily solder the threads to our circuit. In order to make it easier to change your diode or most FET. So you can drill a hole here, so you can put this in at the top and make it easier to switch your detector like this. Alternatively, if you don't want to expose your detector, you can just put this inside. Right, so when you have to change the detector, you can go inside to change it. So up to you, whichever works best for you. Some people don't want to expose their electronic components, so that way you can just leave it inside. So when we finished, we will be covering this, but I don't want to use this metallic cover because it's too close to the high frequency component. We may need to cut a piece of acrylic board and then to replace this metal cover. Yeah, or you can do without metal cover or any kind of cover. Just leave it like that. Okay, what else? So we talk about this 1mm magnet wire. So you can wind a coil using the AAA cell. Okay, so I got an AAA cell. Let me show you where it says AAA. Yeah, 1.5 volt AAA. So this is the AAA cell. It's very thin. The diameter of this is 10mm. Yeah. So we'll be creating a 10mm diameter coil. I think when it finishes, it will be around 12mm because of the thickness of the wire, which is 1mm on both sides. So what we do is we just leave around 2 inches open and then start winding. When you start winding, try to wind it very close together. Don't leave any gap. You just push the wire close together, turn by turn, like this. You don't want to leave much gap, right? Just because otherwise it will be uneven if you leave a gap in between the turns. So if we wind 6 turns, okay, when you count the turns, don't count the first one, count from the second one. Okay, so this is first turn, second turn, third turn, fourth turn, fifth turn, sixth turn. So this is enough 6 turn. Okay, and then you can leave a bit more at the end. I think 3 inch should be better. Leave 3 inch at the end because you may be using the same wire to connect to the terminal of the antenna. So leave 3 inch at each end. 1, 2, 3, 4, 5, and 6 turns. Okay. And then you can cut it out. And like this. And then you can extend it out a bit to around 1 inch. Try to keep the spacing between each turn even. So around 1 inch should be fine. Okay, like this. Okay. And next you need to wind another coil for coupling with the antenna. So this is where you need to determine how many turn you need. If you are connecting to your telescopic antenna, then just one turn is enough. If you are connecting to your foldable Yagi antenna, then you need 4 turns, because the Yagi antenna has 4 times the impedance of a telescopic and a dipole. So that's why here we may need to have 2 different setup. One is 1 turn, another one is 4 turns. Okay. So let me wind the 4 turn one first. So again, let's count the wire. 1, 2, 3, 4. 4 turns. Okay, so don't count this one. Count from the second one. 1, 2, 3, 4. Okay, 4 turns. This is for my folded Yagi antenna, so I need 4 turns. Okay, so that's our coil. Make sure you wind in the same direction for both coil. This one for the resonance circuit, and this one for the antenna coupling. Next, we need to secure this socket in place. Okay, and then we will use the hot glue gun to secure it. Okay, so it's done. Next is to mount this headphone jack. Okay, next we need to put the resonance coil and the coupling coil for the antenna together, and then we need to twist the legs so they come together. This will be easier for soldering, like this. So this is finished. This is the fixed plate, this is the moving plate, the resonance coil, and the antenna coupling coil. So we finished soldering. This is the coupling coil, this is the resonance coil, and we solder to the middle, which is the moving plate, and also the fixed plate. Okay, so now we can install them to the chassis and finish the rest of the configuration. So after we've secured the variable capacitor to the chassis using this screw, we can connect and solder this thick wire to the ground pole here for the antenna, and then the end of the coupling coil, this one, to this screw to the far right as the other antenna terminal. Then the third antenna terminal will be soldered to the second turn from this thick wire in the resonance coil. So this is the one. Then we can continue to finish the soldering. If you look from the top, on the left, this is pin 1, pin 2, pin 3, pin 4. So I've split that into different color. Pin 1 is the brown color thread here, pin 2 is the orange color here, pin 3 is the blue one, and pin 4 is the white one. So we will be soldering them to the right place. Give you a close-up. So this is the 3D printer knobs that are designed, showing all the scale of the FM radio frequency from 88 MHz to 108 MHz. And this is driving the variable capacitor inside. This is the socket for connecting the diode or MOSFET. For this one, I'm using the 3DQ. Let me show you. It's very hard. This is the 3DQ. And there are 3 terminals to hook up the FM crystal radio antenna. You can hook up to the Yagi antenna or the telescopic antenna. So I've included 4 turns for the coupling between the FM antenna and the resonance coil. The resonance coil has 6 turns. I'm tapping from the second turn to go to the MOSFET source gates. For the diode, we are tapping directly at the hot end of the coil to the diode. And then later on we will test this. This other one is the variable capacitor made of plastic. I have tested briefly. The output volume of this one is a little bit low and it's not very clear. So that's because the plastic variable capacitor, the Q factor is much lower than the air variable capacitor. So that's why the slope detection is not that successful, not that perfect, using the variable capacitor made of plastic. This is the impedance matching box that I created using the KPB-02 impedance matching transformer designed in China. KBP02, it has a number of output terminals. It can come with the following different type of impedance, as high as 200K, as low as 4 ohm. So it's a auto transformer, meaning there's no primary stage or secondary stage. There's only one single coil. You can connect the 0 ohm to the ground and then connect the input impedance to one of the terminals or tapping points and connect the other output impedance to the other terminals or tapping points according to the impedance unit. For example, if I'm using a MOSFET, I will connect the output from the crystal detector to 2.5K, or if I'm using the diode, I will connect to 10K. And then according to the different earphone or headphone you have, you will connect to 500 ohm for your magnetic coil headphone, high impedance headphone, or even up to 10K or 20K for your crystal earbud, the piezoelectric or ceramic earbud. And then if you're using the conventional hi-fi earbud for the iPhone or smartphone, is around 32 ohm or 64 ohm. You may have other speakers you want to test that are 8 ohm or 4 ohm as well. So just connect to the right terminal. To make it easier, I created the rotary dial to select from different impedance, and I also connected a meter in case that it has enough current to drive the meter. It will be recorded here from 50 microampere onwards. I have a range meter there that put this meter in parallel with different resistors, so we can measure the different range of current. Okay, and then I have the output terminal for connecting to my earbud, so I can monitor the output. I have another output terminal for the recording, so I can connect this cable, the other end of it, directly to my iPhone's microphone jack for the video recording. of the audio. So there's no amplification involved. The only amplification may be the iPhone's auto AGC, auto gain control, in the microphone input circuitry. Other than that, there's no amplification. So you'll be hearing directly from the source without a speaker or amplification. Okay, and this end is the input. I will plug it into my crystal radio, the output phone jack. So let me plug it in. And then this is the socket that I put in the diode. If I use the diode, I will use the middle two pins where it will drive the output directly. And I will use one of the side pins here that will connect to the hot end of the coil to get the maximum signal through the diode, and we can hear it from this earbud. For the MOSFET, I have connected a small jumper with 4 pins. So on the side are the 2 gates, gate 2 on the left, gate 1 on the right, and then in the middle, counting from the left, the second pin is the output pin, the drain pin, and then the third pin is the source pin, the input pin. So the source pin is the one that I need to connect to the tap of the coil to source the current that we can use to drive the speaker. The gate will control how this current will pass from the source to the drain, and then to the headphone jack, and then back to ground of the circuit. So let me plug in the 3DQ. Okay, then we can connect the antenna. So this 2 wire is 1 mm magnet wire that I extended from my antenna here. This is my window. The antenna is measured 1.5 meter long. There's a elongated paper clip with a brick in the middle here. So that's called a folded dipole. We also call it the Yagi antenna. I can optionally put a few more guiding poles here in the front and a reflecting plate at the back to complete the Yagi setup, but it will be too big and will be blocking the view from my window. So I just need 1 element Yagi, that's the folded dipole, and I connect 2 wires from the brick point here using this magnet wire to here. Okay. You can use the parallel ladder wires, but I can't find that anymore. And for the ones that I can find, I find the quality is very bad. It's not as thick as this 1 millimeter wire, so I prefer to make my own. Let's use the 1 millimeter magnet wire to be used as a feed-in wire for the antenna. So I connect one end to this coupling coil here, and then the other end I connect to the first tap of the first turn after ground, so it will be connected to here. Okay, once I finish the connection, I can flip it back. Put a styrofoam here, it will help to reduce the signal loss of the radio wave, because contacting anything other than this styrofoam will absorb some of the wireless wave. Okay, then we can I can now start plugging in this recording line to my headphone, and then after that you will hear nothing but all the sound from the radio. So I'll stop talking now.
你有收過朱古力咪得咯。 人生嘅嘢邊個唔所謂嘅？好醒目啊！咁啊，多謝。唔單止朱古力嘅，係一個心形添㗎。多謝張敬軒，多謝張敬軒上到嚟，多謝三位。现在地位了。明日日間部分時間有陽光，氣溫介乎19至23度，吹和緩偏東風。初時離岸風勢清勁，展望隨後2日風勢較大。星期5大致天晴，日間現時。
8422點，創超過1個月低8540點，跌557點，跌幅近2%。主板成交接近2768億元，科技指數最多急跌7%，超過6%。京東健康跌近1成1，美團同小米都石油嚟嘅，有個越烈嘅狀況啦。除咗之外，港股咧見到一啲嘅資金咧有流走嘅跡象，港匯咧日內咧亦都係持續咁樣轉弱緊。由港元咁呢方面其實亦都係引發到市場一啲嘅憂慮，佢哋可能都會擔心咧股市嘅經濟咧已經告終啦，從而咧開始咧去沽貨獲利。咁啊，同埋資金輪動嘅狀況幾明顯嘅，啲錢係流入翻銀行股。
Now we are testing the other FM crystal radio that we made using the plastic variable capacitor. Let's see how that works. So I connected the Yaji antenna from my window through this 2-magnet wire to the antenna coil, which is 4 turns, and then this coupled with the resonance and resonance coil, which is 6 turns. For the other end from the Yaji antenna, I connect to this first turn after the ground. Okay, so everything will be the same as the other air variable capacitor, except that the variable capacitor for this one is made of plastic. Let's see if it's much better or even worse. So now I connect the headphone jack, the mic.
董事就提到了建立以国家工业为主体的自然保护地体系，我们将牢记保护好中华水土。
就係暫時仲係演場嚟講，但係都係關係真係到落去到呢個電影嘅熱潮嘅問題。
有個角度，變相影響埋製作電影嘅導演啊，以至即係其他電影工業嘅範疇嘅人士都受到影響咧。呢個
係啊，呢度話你講得，而家啲演呢，而家佢嘅一個嘅員工咧，淨係演嗰邊咧都2800個員工。咁而家拍戲同埋。國紅啊，全部要靠演嘅，你拍完片國紅啲戲演，做佢都有錢受分啊！
总书记的祝福很是温暖，激励着我们继续奋斗。总书记在讲话中还专门点赞了在决胜全面建成小康社会、决战脱贫攻坚等各个战线上我们新时代 受到巨大的鼓舞，给我们肩上更大的一个责任。我们一定会牢记总书记的要求和期望。
Overall, this performance is still okay, but it's not as sharp and as loud as the other one with the air variable capacitor. But interestingly, this one allows me to receive much more stations than the air VC1. I want to let you compare with the dual-tuned 3DQ FM crystal radio that I invented myself. I try to make it a frequency detection circuit, but I'm not too sure whether this is really frequency detection. But no matter what, it has performed the best from all of my testing of the FM crystal radio circuits. So it's using just one 3DQ. It's using 2 coils, 2 tuning variable capacitor, and it's giving me much sharper and much louder output than any of this type of a single tune FM crystal radio using the same FM ERG antenna. And let's come.
李克勤唱呢隻歌呢，原本呢就大家都知道優客李林就係叫做認錯，因為李克勤呢只想你會意嘅，即係佢唔講出口。你想下啦，你感唔感覺到啊？其實我心裏邊係好中意你啊，即係嗰啲啦唉，真係冇鬼用，講出口啊嘛！李克勤嘅只想你會意。
Okay, so comparatively, this one is louder and sharper. But because of the dual tuning, you cannot receive as many stations as the single tuned ones. The other difference is this one I'm using the 2mm thick copper wires for my coil, and the single tune one I use the 1mm copper wire. Okay, that's all for this series. This is the series for the FM crystal radio, and this is Billy. I hope you like this chapter about slope detection FM crystal radio. Thanks for watching. If you like my video, please click like, subscribe, and send to your friends to watch too. If you want to support my work, go to my blog. There's many ways you can support my work, including purchasing equipment or components from eBay or Amazon using my links. Thanks a lot. See you next time.